Hello everyone, so now we are going to discuss about the passive interface. Generally, why we use the passive interface to stop the hello messages. Example, let me take the blackboard. Example, we have the one router. Imagine you have one router that is a R1 and you have another router that is a R2. And this is connected this way. And you have one more LAN network here. Imagine you have the S1 here and you have some devices here working as a client PC here. Maybe PC1, PC2, PC3, some devices are here, and we want to advertise this interface and this interface as well as this interface and this interface in the OSPF. Okay, so when we advertise this interface in the OSPF, hello messages is going to go in this direction also, in this direction also, in our LAN side also. So maybe if anyone in your organization who is playing with your network, maybe he can bring the Kali Linux in his PC and he can also send the hello packets from his PC to your router, and your router will receive the hello message. This guy will say hello, this guy will say hello, and they will have all the packets, all the state, they will become neighbor, all the routes from the R2 he will get that route. So we need to avoid that one. So for that purpose, what we will do, we will put the passive. We will put this interface as a passive, so he cannot send the hello messages here. Same thing we will do here also. So he cannot send the hello messages. And imagine if you are connected with the ISP example, so you can put here also. So even if anyone run OSPF by mistake here in this interface, it will block. Okay. So for that purpose, generally we are using the passive interface. So if you see here, same thing I wrote, like it will block the hello messages, it will block the incoming outgoing routes of the OSPF here. It will stop both outgoing incoming routes from the OSPF. So we will use this one to block that one. Concept is very easy, just we want to block that one. We taken one scenario, we have the R1, we have the R2, we have the R3, and if you see here what we have, here we have one loopback, and this is the IP we are using in between the network, and here also we have the loopback, here also we have the loopback. So we will configure the loopback and we will assign the IP, and then we will run the OSPF. So here I have already the configuration. I use the OSPF by interface method, and then example I want to stop the hello messages here. So I can log into that router, I can check which interface I want to block, I can block. I need to put which interface I want to block. Example, I want to block this one, then I will write the passive interface F0 by 1 as we wrote in our previous class. So let me show you that one. Configuration I have already, no, not this one. So let me show you, because previously we done that one. So we have here passive interface configuration. So this is a configuration, and let me show the topology. We will use the same topology as we done yesterday. So this is a topology. We can compare the IP address if we have the same. If you see here, we have the same IP address here. This is a R1. We have the loopback here, and we have the IP 12.1. So this is that one, and we have the OSPF. So this is only the configuration which we done in our previous class. So we will use that one. Just this configuration is simple, nothing we have big thing in this one. What we are doing, we are assigning the IP address. After that, what we will do, we will enable the OSPF. That's all. After that, we will check we are getting the routes. So then we will block the route. So let me copy that one. I hope you already understand this configuration, or in our previous class I already explained this configuration. This is just we are assigning the IP, and now with this one we are putting that in the OSPF. We are enabling the OSPF interface in this. We are enabling the OSPF on this interface. That's all. Same thing for R2, same thing for R3. This later we do when we want to disable the hello messages. So first of all, let me copy and paste and check all hello messages are coming or not. After that, we are going to look how we can block. So I will go in the R1. This is a R1. I will paste this configuration in the R1. If you see, we are not getting any error. Everything is good. So now I will copy this configuration from here to R2. I will paste this in the R2. So this is a R2 here, and I will paste here. Okay, I paste here this one. So no issue, everything is good, no error, nothing. And what else we can do? We can take this one and we can paste in the R3 also. I will take this in the R3. First of all, let me see here. I done here passive interface command already, so we can remove also, no problem. When I copy paste, I paste the passive interface command also there already, but I can remove that, no issue. Okay, what happened here? Okay, so now let me paste the R3 configuration. This is a R3 configuration. I will paste here. Okay, so now we will have the roots, we will get the roots. Let me remove this one. Just now by mistake I paste this one here, so I will write here no, and then I will paste this one so that he can exchange the root. And now we are in the R3. We can check R3 is getting the roots or not. We can compare that R3 is getting the root from other routers or not. This way we can check. If you check here, what I can write here, I can write show IP root here, or if I want to check for the OSPF particularly, I can write here show IP OSPF, show IP root OSPF. Okay, still I did not get any root here. Let me check, do I have IP correctly? I have the fast Ethernet 0x0. This one I have IP and it is up. Here also loopback, it is up. I want to check OSPF is running or not. Show IP protocol. So if you see OSPF is working here, let's see show IP root OSPF. Still we don't have any root. Let's go in the R1 and check here, do we have the root here or not. Show IP root. Still we don't have here. Let's wait and check in R2 also. Show IP root. Still we don't have here, so it takes some time. And we can check show IP interface brief, all interface is up. Okay, and we can write show run and we can verify configuration, whatever we copy paste, it is correct or not. How we will verify? Just we will go here and we will check. Like here, this is OSPF is enabled in the loopback 2, OSPF is enabled in the fast Ethernet 0x0, and other OSPF is enabled in the fast Ethernet 1x0. And what else we can see? We have the OSPF here, enable this one. And what else we can see? This is nothing. So here is OSPF enable. So we should get the root. Let me write show IP root OSPF, show IP OSPF neighbor. Still we don't have neighbor. It should come fast. Why it is taking long time? Let me check show IP OSPF, show IP root OSPF, show IP OSPF database. Yeah, now it came here. So here only we are advertising 1.1.1. so here this one only we are getting, other roots are not getting. So maybe we miss anything here. Let's see. Here we put this interface F0x0 and here is loopback 1. So let me check in the R1, show IP root OSPF, still not get. Show run. Here we have the correct configuration, I think. Let me verify. Yesterday it is working. Anyhow, let's see why we are having this issue. Loopback 1 is we assign here, also we put OSPF, and this is also okay. So R1 is not having any issue. Let's see R2. Maybe R2 is having some issue. Let me write here show run. Let me check in the R2. Maybe I have any issue here. Show run. And if you see what we can see here, we have here loopback. In this loopback R2 we advertise the OSPF. Okay, and let's see other thing. Here also we advertise the OSPF. So this is also okay. And what else we have here? Here this interface also I have the OSPF. And if you see, everything is good. It should come up. Maybe we have some issue. Let me clear the process. Clear IP OSPF process. Yes. So let's see. Here also let me write And let's see here, this is a no shut we write here, and loopback no need to write no shut, but for the this one no shut we write because all our interface already up, right? See, somewhere we miss no shut, here is no shut, so no issue for no shut. Anyhow, let's see show IP OSPF database. We are getting only our database only. Let me clear IP OSPF process. Yes, still they did not form the neighborship. Maybe something issue we can trace there. Maybe if router ID is same, both guys are having the same router ID, we will have this issue also. If anyone change the hello timer also, we will have this issue. But anyhow, let's see, do we change any router ID? We can write show IP protocol, and we can check here this router ID is 1.1.1, and the R2, what is the R2 router ID? Show IP protocol, here is the router ID 2.2.2, and in the 3 we will check, we will have the show IP process, show IP protocol. Here is the router ID is 3.3.3. so this is okay, this is okay. When we copy and paste something we notice here, let me check here what, when we paste here, we created loopback, this one we assign here OSPF, okay, and this is good, no issue here. Then why we are not getting root here? Let's see in the R2, maybe in R2 we have some issue. Let's see here, show IP root, still not show IP OSPF database, only our database only. If I write show IP protocol, this is correct. What else we can do? We can write clear, I think we already clear, but anyhow let's see, show clear IP OSPF process, yes. What we can do, we can say check here, show IP interface brief. Let's compare the IP address, we have correct or wrong here. This is the R2 is having fast Ethernet 0/0. Okay, here we have the issue. If you see here, R2 is having some issue, I think. If you see, this interface is fast Ethernet 0/0, okay, but if you see here what we done here, fast Ethernet 0/0, but we assigned this IP. If you remember in our previous class, we told whenever we are making the neighbor, there should be in the same subnet. But if you see here, this is a R2, okay, this R2 fast Ethernet 0/0, what we assign? We assign 192.168.23.2. 23.2, if we write here will be 12.1, then they will not form the neighborship. This should be in the same subnet. So here we have the different subnet, okay, here is the different subnet because we use this different topology. This is not the topology which we done previously. But anyhow, if we want to use this one, we need to correct here the interface. Which one I am saying? This interface. Fast Ethernet 0/0, this is okay, no problem for R1. But R2, if you see here, fast Ethernet 0/0 should be 12. So this should be fast Ethernet 0/0. This should be fast Ethernet 0/0. This one. Interface fast Ethernet 0/0 will be in 192.168.12.2. Then fast Ethernet 1/0. So this should be 1/0. 1/0 should be 23.2. Okay. And then after that, this will remain same. If we go here, this one fast Ethernet 0/0, this will be remain same. So only in the router 2 we have the issue. So how we can fix? We can go here, okay, we can go here. Let me go here, I will go in the configuration, then I will go to the interface. See, this is also a small troubleshooting, okay, some troubleshooting. What we done, we assign the different subnet. Oppositely, like example, these two router are connected directly, so they should be in the same subnet. What we done, because I use the different topology, this is for the different purpose, I open this different topology now. In our previous class, the lab which we done, that is a different diagram. As per that diagram, this configuration is there. but here we have different layout. That's why we have the issue. If you see, this is a fast Ethernet 0 by 0, but we assign here fast Ethernet 0 by 0, we assign 23.2. It should be 12.2. Here will be 12.1. Here should be 12.2. Here should be 23.1, 23.2, and here should be 23.3. This IP remains same, only here will change. But here we done something wrong. That's why it is not getting. So what I will do, I will correct that one. So I will go here in the interface fast Ethernet 0 by 0, and then I will write no IP address. Okay, I remove the IP address. Then I will assign the IP address. IP address 192.168.12.2, 255.255.255.0. Okay, he is saying overlapping. So because we assign this IP to other interface, which interface? Interface fast Ethernet 1 by 0. We assign this IP to that one. So let me remove there also. No IP address. I remove there also. Now I will go again. Interface F0 by 0. Then I will write here IP address 12 dot this. Okay. Now I will write no shut. So this way I assign. Why I get this overlap? Because what I done here, I assign this IP to this interface. Okay. And this IP to this interface. What I done, I remove the IP, this IP, and I assign this IP. So we are getting already this IP is assigned here. That's why I am getting overlap. So I remove from here, then I done. When I done, automatically adjacency form. Okay. So this other interface also we need to fix. In the real scenario also we will get these types of issue. Sometime we are in the hurry and we will copy paste. We will not notice that one. Later we realize, okay, this wrong thing we done. Okay, so now I will do IP address. This is 192.168.23.2, 255.255.255.0, and then we will write no shut now. So here also we are going to get the neighborship for this side also. Okay, let's see. Yeah, here also we get the adjacency. Here also we have the OSPF. Now we can check show IP root OSPF. We will get the root. We are getting the root here 1.1. We are getting here root as a 1.1. This root we are getting here. And if we have here the 3.3, we should get that root also. I think we have or we not. Let me see here. We have loopback 3 and we assign. So we should get loopback 3 also. Let's see why it not came. Here they form the OSPF neighborship. Let me check show IP root OSPF. Here we get the 3 roots, so we should have here also the other root. Let me again check. Yeah, we get the other root also here. So if you see here, I am getting this one from OSPF, this one also from the OSPF. Means, let me show you what I am getting here. I am getting this root as well as here I have the 3.3.3 loopback. That also I am getting here. And if I check here, I will get here this one and this one. But imagine this is your LAN network. Okay, imagine this is your LAN network. You don't need any roots here. So what you will do, we will enable the passive interface here. So how we will enable? Just we need to go to the R2 here, and then we will go here. We will go in the global configuration mode. Then we will go in the OSPF router OSPF1. Then we will write passive interface and give the interface, which interface you want to enable the passive. I want to enable here fast Ethernet 1 by 0. So now it become passive and hello messages will stop, it will block, and then this R3 will lose the roots. It will take 40 seconds. If you remember, we have the hello timer, dead timer. So after dead timer finish, R3 will lose all the roots whatever is coming from the R2, because we enable the passive interface. So now after 40 seconds it will remove from here. We need to wait some time, we will get that one. Okay. After fire, if you see here also show IP root OSPF. If you see, already stop from here, and here also we will have the here. If you see, expire hello timer, dead timer expired, so we will not have the roots here. If you see, no routes. Why? We enable the passive interface. So what we can say, we use the passive interface if you want to block the hello messages. So in case if you want to do the lab, you can do in the packet tracer also. Take one router here, take another router here, take one switch here, and take one switch here, connect the PC here like this, and run the OSPF here, 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 and take one more router, connect here. Imagine this is your PC, and assign the IP and run the OSPF here. See, this will form as a neighbor, and put the passive interface here, so it will block the hello messages going from here to here. You can play like this. In packet tracer also you can do this command. Okay, so this one we done here in the EVNG. You can do EVNG, GNS or packet tracer, all three are working. So this is a configuration, and this is a different topology. That's why we get this issue. In our previous class, what we done, let me show you. I will close this router. This is the different lab, I think. Yeah, if you see, we have the other lab for passive interface. Passive interface. Let me show you. We have OSPF passive, some name we give in our previous class. Load balance, this path selection, we have this one. So if you see, this is different one. Okay, this the configuration is for this topology, not the topology which we use just now. We use another topology. Which one we use? We use for the OSPF filter. This one we use. Okay, I hope you understand that one, why we get the incorrect and then how we correct. So let me stop this record.